Hello friends, this is our problem valid parenthesis. Passed inside R is valid function by str from s to str. This is easy and to do step here. Now let me explain you all this whole code solution from the scratch. This is a question problem valid parenthesis lead having three cases of parenthesis: opening round bracket, square bracket and curly braces. And for these opening parentheses we need to match the same closing parenthesis corresponding to it. Then we can say that our given string is valid, and for valid string there are these three conditions given to us, so that for which we can say our input string is valid. See this 3 points correctly. These are those three rules, and after these rules there are these examples, and for these examples output is given. See that this opening is round and this closes a square bracket. So this is invalid, that's why our output is false. And this is true because for every opening parenthesis we have the opposite closing parenthesis of it. This case this is invalid because here this round bracket not match with square bracket, and this square bracket not match with this round bracket, so this is also false. And we are also given with our constraint string dot length. Maximum we can take our string length up to 10 to the power 4, and our string consists of parentheses only. This means it says character. In our string this parenthesis must occur. Now let's move on to our solution explanation. Okay, so inside this function, after passing or given input string str, we have created the stack, or you can say we have taken the stack. Initially this stack was empty, and then we have run the for loop on this given string, okay, from 0 to, by using this pointer I, from 0 to its whole length, string length, and incrementing this. And then what we did after it, we have to push the characters occurring in that string at some index I, while we traversing that string from 0 to its whole entire length. Okay, so that characters are here represented by a string of I. We are pushing inside the stack st.push string of I, means at every index of string we are getting the characters. So this str of I this string of I string str of I at every ith index, value at every ith index of that string we get this character, and we are pushing into stack. We are doing this. Here is returning push character occurring at ith index of string. after that we return false. Just leave this condition. When we push the characters inside the stack from the string, just after checking this condition, if we found any opening parenthesis, any one of these three, if we found any one from these three opening, then we push it into the stack from the string ith index. This thing's string ith index. Okay, and it's this initial cases, if cases, found opening, and its else cases, found closing. Means we found the closing parenthesis corresponding to this opening parenthesis, which is at the top of stack. Then we found closing bracket corresponding to the opening bracket of our top of stack in the string. Okay, then we will here pop from the top of stack, but here this is the condition. Stack top pe we are getting the opening parenthesis and simultaneously found its closing corresponding match at the ith index of string, or this curly braces opening we found at the stack top of stack and simultaneously found closing curly braces at the ith index of string, or this third case might occur. At the top of stack we found the opening square bracket and at the ith index of string we found its closing pair, closing square bracket. Then here in this case we will pop from the stack top opening pairs. We have applied here or condition. Why this is because if we got any one closing from this three types of parentheses, if we got any one type of closing parenthesis corresponding to its three opening parentheses, then we pop its corresponding opening parenthesis from the top of stack. Okay, but before this condition we have checked that is our stack empty or not. If our stack empty, then we will return false here, because false means our string is invalid, not valid. So till after this else cases is of found closing. So after this else case we checked for if our stack is empty, so we return false. Means this if cases of, since we are using this checking this if condition after this inside this else, which is of found closing. So this if states that closing quantity of closing parenthesis is more than opening parenthesis, closing parenthesis is greater in quantities than opening parenthesis, so our string is obviously invalid. And here is the perfect case. If closing match with opening, if any one of this closing match with opening, simultaneously these two things occur simultaneously, and any one of these three takes place. That's why we applied OR here. then we pop from the top of the stack. And this else case is of no matches, which is inside this else case found closing. This found closing wala, this else case is no matches. This else case is opposite of this if case, where we got corresponding closing match of the opening parenthesis, where we popped the top element from the stack. But its else cases, we have not found any single match corresponding to the top of our stack. Our closing parenthesis does not match with the opening parenthesis which was found at the top of stack. So here we return the false. False means again invalid string. And after the end of this is for loop, and after its end we return this stack size 0, means empty stack. Empty stack means we have finished each and every. We cancelled popping. This is at the end, and last we return our empty stack when we got our stack empty after popping the top element. When we got corresponding closing character every time which matches with the opening character of the opening parenthesis. At the last, when we return this thing stack empty, means we are not having any residual character. So it also means that our string is valid parenthesis, and its opposite case was that our stack size is not equal to 0, that our stack is not empty. Stack is not empty at the end. After doing all the operations, we remain with our stack left unempty. It means our given string is invalid because we have not popped each and every element of the stack top with the closing parenthesis that we found on the ith index of the string when it matched. But in this case, stack is not empty means at the end our stack top does not match with any ith character of the string. That's why our stack top element not get cancelled. That's why we can say that our string is invalid. But here at the end we need to return our answer, which is stack is empty. So this is final. Okay, so at the last we have written our stack size equal 0. We are not directly saying that our stack is empty. We have used here double equal to. If this condition is true, this much I have shaded, if this condition is true, then it means we have all opening brackets matched with the corresponding closing ones. So this is the case of when our stack becomes empty at the end. and if this condition is false, then it will return us, means if this condition is false, it means our stack is not empty and we have opening bracket left unmatched with the closing bracket, means here our opening brackets are more than our closing bracket in quantity. This is opposite case of that we just did above. This is the case when our closing bracket was more than our opening bracket, and this condition we did inside this else.